Well, we're here to discuss just a little bit about engineering economy decision making. And there's basically 7 steps in this procedure to making a decision um, from an engineering economy viewpoint. So the first would be recognizing, defining, and evaluating whatever the problem is. So that's the first thing we need to do is identify what it is that we're trying to solve. The second thing is we need to search for the feasible alternatives. How can we solve this problem? So that's not necessarily going to be found in numbers. You need to know if there's a problem on a production line somewhere, you need to figure out how to fix it. If there's not enough capacity in an area, you need to know how you're going to address that capacity by getting additional equipment. Don't be surprised if you're working only one shift on an existing piece of equipment if you're asked to run a second or third shift. That may be needed to get increased capacity. Then we need to look at, well, where are we going to get the cash from? And how is the cash going to flow out of the company? And you'll find that cash flow is very important to many decisions. Sometimes alternatives will be selected based on when cash will be available from the company. Now, as an engineer, you're probably not going to know that by yourself, but you need to know to ask the question. The chief financial officer or somebody in cost accounting will help you with that type of analysis. The decision definitely needs to serve the long-term interest of the organization. So you have to make sure that your solution is in line with what the organization needs. And the perfect solution may not be what the company really needs or wants. Sometimes the cost of being perfect is very, very high. And so being adequate and giving the proper amount of quality may be the answer that the organization wants. Then you need to analyze the economic aspects of the engineering problem. And then that means going through and doing all the calculations you're going to learn in chapters. Well, you learn them throughout the book, but it's the approaches in chapters 4, 3, 5, 6, and 7 that will help you most. Chapters 1 and 2 get your head straight about how you're going to be thinking about engineering problems and solutions. Chapter 3, I prefer to have you look at chapter 4 first, then go to chapter 3. Chapter 3 becomes pretty intensive. Chapter 4 isn't so easy. Chapter 6 and 7, well, 5, 6, and 7. 5 is a little bit tough, but by that point, if you're understanding what you learned in 3 and 4, in chapters 6 and 7, you're just applying those techniques. So from my viewpoint, the course gets easier. Then finally with chapters 11 and 14, as engineers, those concepts that are presented there will probably just make sense to you. Well, the preferred alternative is based on, it's a total effort, your numbers and what you'll learn things in chapter 11, chapter 14 about making decisions when not just money is in consideration. Then after you've come to your decision, you want to make sure that you're listening for feedback about how improvements are happening for the company. So there's a few things to help with engineering economics. If you've taken microeconomics, then engineering economics, um, they're very close, they're very related. Uh, Engineering economics is devoted to problem solving and decision making at the operations level. So this is really focused on companies and businesses. So engineering economics can lead to um, helping to meet company technical objectives and sometimes at the expense of strategic effectiveness. So we're making tactical decisions based on finances. Uh, One thing engineering economics can do is to help you identify where there are limited resources and to select the preferred course of action. If you're looking at a manufacturing line, for instance, one thing you don't want to do is add capacity after a piece of equipment that doesn't have enough capacity to feed it. So this is what an engineer does, is looks at the system. We're just not always focused on individual parts. We have to look at how the system plays together. Um, Engineering economics is very pragmatic, and it removes complicated abstract ideas that you see with economic theory. It, um, the danger of that side is, as engineers, we can be pretty specific people. And just because a number tells you that a decision seems to be right, don't fall into the trap of believing that your numbers are the end all reason to make a decision. They're a piece of information that plays in with some untangible aspects of the organization. So you have to be willing and flexible as an engineer to uh, adapt and not get frustrated and aggravated. You just need to adapt. Um, you know, engineering economics uses uh, the economic concepts and principles to make decisions, and engineering economy links the economics with engineering practice. It's extremely important that you understand engineering economy and how it affects decisions. You know, probably every course any faculty member teaches, they state that this is the most important course that you're going to have. Um, I think that most faculty members who have spent any time in the practical real world would come back and tell you that today you have to understand how to make an economic decision that makes sense from an engineering standpoint. That's probably the most important decision making process that you can develop. So I hope that this course helps you uh, get prepared for that. There'll be many things that you learn on the job, but in doing financial analysis as the way your company wants done will be one of those things, but this course will provide you the foundation for that.